Hello and welcome to another video on proof for A-level maths. In most A-level textbooks, you'll find a standard proof that root 2 is irrational. But an exam question could ask you to prove that root 3 or root 5 is irrational. So rather than take root 2, let's have a look at root 3. The standard proof is a proof by contradiction. We assume the opposite is true, that root 3 can be written as a fraction where a and b are integers. We need to add an extra condition, that the fraction is fully cancelled down, that a and b have no common factors. If they have no common factors, then a and b cannot both be multiples of 3. Otherwise, the fraction is not fully cancelled down. Let me add, if the question asked us, say, about root 5, then we would be making the same statements but noting that a and b cannot both be multiples of 5. So taking root 3 equals a over b, we can square both sides and make a squared the subject to get a squared is 3b squared. That tells us that a squared is a multiple of 3. Which in turn tells us that a must be a multiple of 3. Hence we can write a equals 3 times p, where p is an integer. Going back to a squared, we can replace the a with 3p, square the bracket, and divide by 3 to get b squared equals 3p squared. You can probably guess what comes next. We can now see that b squared is a multiple of 3, which again means that b must be a multiple of 3. Hence, a and b are both multiples of 3. In other words, they have a common factor of 3. But we assumed at the start that they have no common factors. We have a contradiction. Our assumption must be wrong. Root 3 cannot be a rational number. Root 3 must be irrational.